So you want to know if your design will hold up? Well, in this video, we're going to show you how to quickly use SolidWorks Simulation to validate your designs so you can know for sure if your design is going to hold up. In this video, we're going to do it in two parts. So first, we'll walk through the 6 key steps you need to know so you can get started. And then we'll dive a little deeper to make sure everything's set up correctly and show how you can use simulation results so you can improve your design. So let's jump in. We start up top here at the ribbon. We're going to grab the simulation tab on the command manager and click new study. This is where we choose the study type. For this example, we'll do a static study, and that just means the model's held in place and we're testing to see if it'll hold up under that loading. So I'll give it the name strength test and hit the green check mark. Now here's the best part. The 6 steps that we need to follow are listed right here: material, connections, fixtures, loads, mesh, and results. Just work your way down from top to bottom and you'll be set. Let's get started with step 1, material. First, we check our geometry. You'll see that we've got solid geometry. We know this because that icon confirms it. And by the way, it's curved and squiggly like that because we're using high quality elements. So let's right click and apply material. We click apply, edit material. This brings up the simulation material library. Now it looks a little different from the regular one you're used to in SolidWorks CAD because it highlights the required values in red. Now that's all we need to know to run the study. For this bracket, I'm going to go to the aluminum alloys and choose the classic 6061 T6. Checking it out to confirm we got all the red values filled, and I'm going to hit apply and close to apply the material model. And now we're on to step 2, connections. So this is a single body part. And you know what's good about that is we can skip it. There's no connections here. There's no interactions. These parts aren't coming into contact because there's only one. So we'll move right past it and on to step 3, fixtures. Fixtures tells simulation what can and can't move and how. So I'll right click on fixtures, choose fixed geometry, and select these faces here. Think of this as a super simplified version of a bolted connection. So with these 2 fixtures, it's now locked in place, and that's all that we need for now. Click the green check mark to confirm, and now we're on to step 4. Here is where we'll apply our external loads. In this case, it's a bracket, and I want it to hold 50 pounds straight down. So right click external loads, choose force, and as I move the cursor over, you'll see lots of visual feedback. I'll select the cylindrical face, and by default, SolidWorks applies the force normal to the face, which means directly on it. So I don't want that. I want it going straight down. So I'll apply it to that face, but give it a selected reference. You can select any entity, a plane, face, edge, something that you can then reference to tell it exactly which way to go. I'll pick this edge because it really simplifies things. And it says it's in that direction. I'll key in the value of 50. Look at the arrows to confirm. Click the green check mark to lock it in. So now we have our 50-pound load. We're on to step 5, meshing. With the model set up like this, we're ready to go forward with meshing. Now we can right click and hit mesh and run and just go for it. The auto mesher is robust, accurate, and it works most of the time, especially for a simple part like this. If you want more control, you can adjust the mesh size. This slider here is unique for every model. You can move it to the right or left for coarse or fine, or you can go into more values: standard mesh, curvature-based mesh, blended curvature-based mesh, changing the meshing algorithm here, and then moving the slider from right to left to really get this dialed in exactly how you want. Once we click the green check mark, we're ready to start meshing the model, breaking it down into this finite element model, which we'll then use to run our FEA. So here we can visually inspect the mesh. We see it's broken down into a lot of tiny pieces, and this is where it's going to solve those FEA equations. Right click at the top or go back up to the command manager and hit run this study, and we'll instantly get our results. So, is it going to hold up that 50-pound load? Let's take a look. Here's what we see. Let's switch from stress to displacement. Now, keep in mind, this view is exaggerated by 3.5 times, which we can see from that deformation scale on the top, right? It is about 1/8 of an inch in displacement. To really get an idea of this, I can right click on it, hit animate, and it starts to really animate that deformation. I'm not totally thrilled with how much it's moving, so let's go back to the CAD and make a design change. Here over in the Model tab, I have a configuration set up with a stiffening rib added. I'll switch to that and then create a study by not duplicating the efforts, rather reusing what I already have. What I'm going to do is right click on that tab in the bottom, strength test, and copy it. Right click, copy study. It will take everything from that previous study, the material, force, fixtures, mesh, and rerun it. So let's give it a new name. Click the green check mark to lock it in. Activate the SolidWorks configuration. You'll see the rib, you'll see the fixtures, the loads. We're ready to go. Let's hit run this study. And it's the exact same simulation. Now with that stiffening rib added, let's see if we made some progress. We're at 0.104 inches. It's a little bit better, but not good enough. So let's go back to the model and we can increase the rib thickness. In this case, instead of it being 1/8 of an inch thick, let's go to a 1/2 inch rib and we'll rerun the study again. So here we are in the CAD model. I can edit the feature. I can change the size here. It's 1/8 of an inch. Let's change that, double it. No, 4 times that. Let's make it 1/2 an inch and let's see if that makes an impact. Again, let's look at the displacement and see what happens here. And now we're below that 0.1 inches mark. Better. That's not a huge difference. And you know what? By doing that, iterating on this model multiple times, tells me something interesting, that the rib thickness might not be the critical factor here. Instead, let's try to modify that rib geometry and let's get crazy with it and change its location here on the bottom to be, instead of 3/8 of an inch, let's just click that, drag it, move it, and go up to, I don't know, let's say 1 inch. So all we're doing here is making these changes here, trying to get some valuable insight into our design. Just hit run, still the same setup, same everything here, just a different shape. Now we're down to 0.073. Now we're down to 0.083 inches of displacement. And this is why simulation matters. It's not just about guessing what might work. It's about using your data to guide your decisions. You can make changes and test them quickly, and you can see what's really making a difference. So you have informed decisions on all of these designs. So let's wrap this up. The 6 steps to running a basic simulation in SolidWorks Simulation are materials, connections, fixtures, external loads, mesh, and results. And once you've got that down, you're in control. Testing, learning, and improving your designs every step of the way. Hope this video helped. Give it a like, subscribe for more bite-sized engineering tutorials.